This table shows the scores of 20 people who took a licensing test, and they want us to find the mean and standard deviation. Now what they've done, this basically means that 7 people made a 73, 1 person made a 74, 3 people made a 79, and so on. So they've created a frequency table so that instead of having to add up 20 numbers and divide by 20, we'll still have to divide by 20. So these are our x's. These are our frequencies. So if we take each x times the frequency, 73 times 7 is 511. 74 times 1 is 74. 79 times 3 is 237. 87 times 6 is 522. 88 times 2, 176. 100 times 1 is 100. So we've added up all of our numbers. So we need to add up all of our numbers and divide by our numbers. The x bar is the sum of the x's divided by the number of numbers. So n is going to be 20. This adds up to 20. This adds up to 1,620. So the sum of our x's is 1620 divided by 20 gives us 81 as our average. The standard deviation is the average of the distances of the x's from the mean. Your standard deviation is a measure of how far away from the averages, away from the average, that your data elements tended to land. We would have the same average if all 20 people had made an 81. So the average would be the same. This gives us some additional information about how far off of the averages the numbers actually fell. So first of all, you want to get the distance between the x value and the average. However, keep in mind that there are 20 x values here. There's 20 scores. So to prevent a negative distance from simply canceling out a positive distance so that it would appear that the average distance was always 0, just like if everybody made it 81. So that's not what we're wanting. We're wanting to take the actual distances. So if you have a bunch of people make 3 less than 81 and a bunch of people make 3 more than 81, we want to show that the average distance was 3. So what we're going to do is we're going to get the distances between each of the x's and the x values. And then we're going to square them to do away with them being positive and negative. And we would still have to do this 20 times, but again, with a frequency table, because a number of the numbers are duplicated, we can just take these distances squared and multiply it by the frequency with which that happened. The difference between 73 and 81 is 73 minus 81 is a -8. The difference between 74 and 81, 74 minus 81 is a -7. Now we're going to do that all the way down. And then we're going to take these differences between the number and the mean and square them. So 8 squared becomes 64, -7 squared is 49. We're going to multiply those by the frequency with which it happened. So 64 times 7 is 448. 49 times 1 is 49. Now I'm going to go ahead and fill in the rest of this. Okay, so I've filled in all of these columns, the distance between the x value and the average, which will be positive or negative depending on whether it's above or below. But then I'm going to square each of those, which makes it positive. I'm going to multiply each of these times the frequency so that I can do it 6 times instead of 20. And now what I want to do for my standard deviation. So we're going to take the sum of the x minus x bars squared times their f, multiply by the frequency before you sum them. So this turns out to be 1184. It's going to be divided by n minus 1, which is 19. And then we're going to take the square root to even out squaring it. And I get 7.894. And that's the right answer.